Highlighter. Log equation. Log equation is an equation where the variable x is inside the logarithm. That is what makes a log equation. Here's our first exponential equation. We know this is an exponential equation because we have x in a logarithm. Did I say exponential equation? Yeah, that's totally wrong. We know that this is a logarithmic equation because x is inside a logarithm. Now, when you guys have gotten really, really good at solving exponential equations when the x is in the exponent. And one of the things that exponential equations got you to do is you had to expand things. So we had the logs as the left-hand side. You had to expand things completely in order to solve them. And back when we were working with logarithms in 5.4, and I said 5.4 is all about just practicing skills, where you expand, and you're like, expand, 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 and then simplify. Oh, bringing them all together, bring them all together, bring them all together. And why were we doing this? Well, we've now seen that the expanding part really helps us solve exponential equations. The opposite is true for logarithmic equations. Logarithmic equations, you're going to want to simplify, simplify, simplify. And our steps for solving logarithmic equations step 1 is to simplify. Write as a single log, aka you want to simplify things completely. So you get an equation with only one logarithm. Secondly, once you've got an equation with only one logarithm, you will change to exponential form. This is the hardest step. I don't know how you're going to remember it. We're going to highlight that step in green. We're going to put smiley faces around the step, right? Right? Winter just ended. You want to forget the snow. Don't forget the snow, don't forget this step. No, maybe forget the snow. Maybe that's not a good. Okay. This is the important step. We're going to keep referring to this. This is the one that is going to be hard for you. Then number 3, you're going to solve for x. And finally, and we'll write out all of these steps, and we're going to solve some questions so we know what these things mean. Because the last thing is we're going to check for extraneous roots. These 4 things are important for solving logarithms. So question number 1, we're solving this. Log 3 of 9x equals log 3 of x plus log 3 of x equals 4. How many logarithms do we have? 2. We do not have a single logarithm. So our main goal is to start off by getting a single logarithm. And what happens when you add logs if the bases are the same? You can multiply. So step 1, we can write this as 9x times x. Are you okay if I write that as 9x squared? Yes. Equals 4. Step 1 completed. We have written as a single logarithm. Step 2. How do you get rid of a log? You use the definition and change to exponential form. What does this mean? This means the base is 3, the exponent is 4, is equal to 9x squared. In other words, we have changed it to something that looks like this. 81 equals 9x squared. Have you ever solved something like that before? No? No, never. Well, something similar, but I don't know if I've ever had the 81 and the 9. Maybe that's what happened, right? So what do? Well, we divide both sides by 9. How do I get rid of x squared? I square root both sides, and I get plus or minus 3. In fact, I'm going to write them both out separately. X equals 3, x equals minus 3. Solve for x. Step 3 done. So if I'm just going to, I'm going to write where we did things. Right? Check for extraneous roots. We're going to add something to that on the left. What does it mean for an extraneous root? What is an extraneous root? An extraneous root is when you get an answer that appears to work because you did all your math right, but when you check it, it actually doesn't work. In this case, the -3 is going to be an extraneous root. How do we do that? Well, when you're checking for an extraneous root, you can't take the logarithm of a negative number or 0. And the reason for that, you can just think graphically. What does a basic log graph look like? Well, it has an asymptote at x equals 0. And its shape is like this, going through 1, 0. That's every single log graph looks like that, no matter what the base is. What's the domain? X is greater than 0. What happens when you plug in a negative? Nothing exists. What happens if you plug in 0? You run into that asymptote. So logarithms domain is x is bigger than 0. So anytime you put a negative number into a logarithm, you have a problem. So let's go through our whole equation. Let's check 3 first. Where do I have logarithms in this equation? I have it right here. If I put 3 in here, will this be a negative inside? No. What about the original equation? If I put a 3, 3 times 9, 27, is that a negative number? No, that's good. 3 into this one, it's a positive number. 3 works. So we're going to go down here to where 3 is, and we've verified that that has worked. Well, we haven't verified completely, because verifying completely means check it, solve it, figure it out. But as long as it's a positive number and you haven't done any math wrong, it will work. But as soon as you go to -3 and you go back to your original equation, can you see that if I plug in -3 right there, 9 times -3 is -27. You cannot take the log of a negative number, so we have to put an x through this one. Okay? So now that we've done all 4 steps, here's the 4th step right here, got everything right, we got 4 out of 4. Okay? How many marks do you get if you did this on the exam? Square root of 9 is plus or minus 3. I know minus 3 doesn't work, so x equals 3. How many marks do you get for this one on the exam? I did it right. I'm going to get 2.5 out of 4. Okay? Why? I lose a half a mark for not showing plus or minus, and I lose a full mark. Now, it differs on exam to exam according to the marking guide, but I lose a full mark for not crossing out an answer. Okay? When you have an extraneous root, You have to really show that you cross it out. Okay? X equals plus or minus 3, x equals 3. 3.5 out of 4. You didn't cancel out the extraneous root. You didn't put I don't know that you for sure know that it doesn't look like that. Maybe you just decided to write one of them. So you have to show that you have an extraneous root and you're canceling it out. Questions for practice on this one, which we're going to do later, are 3, 4, and 5. No, that's not right. I'm on the wrong numbers. Questions for later are 3, 4, and 9. What a recovery. See that? The best looking 9 you've ever seen. Excellent. Okay.